In these notes, we are going to be graphing from 5 points. In 3.12, we learned how to graph from 3 points, which is what we already know, which is the first 4 steps of our notes. We're going to be adding a 5th step to the notes, which is finding the x-intercept, as we already know. So, the equation that we're being given is given in standard form. Remember, it is ax squared plus bx plus c as a formula. Our first step is to find the x value. We use negative b over 2a to do this. Our a is 1, our b is negative 6. So remember to put a negative for the negative in the equation, as well as a negative 6 over 2 times 1. 2 negatives will result in a positive. 6 divided by 2 gives us 3, so the x value is 3. Therefore, our axis of symmetry is also x equals 3. So I know that if I were to go over to 3 on the x-axis and draw a vertical line, that is where, or that will be the middle of our graph. Our second step is to find the y value of the vertex. We find this by plugging in the x value into the equation to find y. So our equation is up here. I'm going to plug in 3 wherever I see an x, which is in 2 locations. This results in 3 squared minus 6 times 3 plus 5. 3 squared is 9. Negative 6 times 3 is 18 plus 5. 9 minus 18 is negative 9 plus 5. Negative 9 plus 5 is negative 4. So our y value is y equals negative 4. So now we have our vertex, because we have both points. So the vertex will be 3, negative 4. So I'm going to go ahead and plot that point on my graph. So now we have one of the 5 points. Our third point is to find the y-intercept. Remember, the c value of the function is the y-intercept. C is the constant, which is the number by itself. 5 is our constant, so we are going to put a point on 5 for the y-intercept. And that would be the coordinate. We're now going to reflect our y-intercept over the axis of symmetry for our third point. 1, 2, 3. So it's 3 to the left. I'm going to therefore go 3 to the right. So now we have 3 points. We just have 2 more. So this is where we're adding a new step. We're going to find our x-intercepts, and we're going to do that by factoring. So our equation is x squared minus 6x plus 5. X squared goes in the first box, 5 goes in the second box. We want to think of 2 numbers that multiply to 5 but add to negative 6. So the only multiples of 5 are 5 and 1. So those are our only options. Now I can get to negative 6 if I make both of them negative. So this will be negative 5x and negative 1x. Now I'm ready to factor. I can factor an x out of this column. I can factor a negative 5 out of this column, factor an x out of this row, and a negative 1 out of this row, giving us x minus 1, x minus 5 in factored form. Now, we set this equal to 0 in order to find the x-intercepts. So individually, I'm going to solve each one of these. First, I'll solve x minus 1 equals 0. I add 1 to both sides and get x equals 1, which is therefore my first y-intercept. My second y-intercept, x minus 5 equals 0. I add 5 to both sides, giving me x equals 5, which is my second x-intercept. I'm now going to go to my graph and plot both of these points. And you'll now see that we have 5 points on our graph. This is the most accurate way of drawing our parabola. Five points when you can is always more accurate than graphing 3 points. Therefore, always use these steps to find those 5 points.